All right, here are some answers to and work to problems dealing in section 6.5. This first question here, you have a negative 2 times 1 plus the square root of 3i, and you're supposed to represent it graphically and then figure out what the trigonometric form of that point is. So if we look at this graphically, and then you distribute the negative 2, you would get a negative 2 plus negative 2 times the square root of 3i. And so that would be to the left 2 and down to right there. And this is a negative 2 times 1 plus the square root of 3i. And so then you're trying to represent it as the trigonometric form. And so in the trigonometric form, you have to figure out what the radius of the circle is, or the absolute value of it is, or the length of the vector, however you want to look at it. And you can use either this or this form of it to do that. If you use this form up here, you would take a negative 2 squared plus a negative 2 square root of 3 squared. That becomes 4. That becomes 12, which is 16. And then the square root of 16 is 4. So that length right there is 4. If you use this form, this part in here is dealing with a radius of 1, and so, or no, it's not dealing with a radius of 1. Let's see. Start that over. This here is 1 squared plus the square root of 3 squared, and then 1 plus 3, which equals 4, and then the square root of 4 is 2, and 2 times 2 is 4. Yes, it's a negative there, but remember this is a distance, and distance is always positive, so that's why it's 4 that way. Alright, so now we know that this is 4. Now we have to figure out the angle, which would be the angle that starts here and goes all the way to there. First, though, we need to figure out this angle right here. And in order to do that, if you use this method, remember theta equals the inverse tangent of the square root of 3, the I part, over the real part. And so then we don't need this thing here, and so we have inverse tangent of the square root of 3, and so theta is a 60-degree angle, or pi over 3. But now if you look at it up here, doing the same thing, theta would equal the I inverse tangent of the I part, because that's y over x. And if you simplify this fraction, you still would have inverse tangent of the square root of 3. And so theta is still 60 degrees, or pi over 3. And then because we're in quadrant 3, we have to go from here all the way to there. And since this part here is 60, that part from there to there is 180. So now we have to add those two things together to get 240 degrees is what our angle is, which is 4 pi over 3 in terms of radians. And so then you can write this as 4 times cosine of 4 pi over 3 plus I sine 4 pi over 3. And then you are done. Moving on to this second question, you are supposed to represent z, z squared, z cubed, and z to the fourth. So z is just equal to this by distributing that. And so that square root of 2 over 2, square root of 2 over 2 is right there. This radius would be 1. And there's z. Now to get z squared, first you probably should convert it to the trig form of it, or you can just take your calculator, put this whole thing in parentheses like this, and square it. And if you do that, you get just plain I. Or you can take this thing right here and square it. Now, how do you square this in your calculator? You can put this in, find the I value in your calculator under Casio. You go to OPTN, and then find where it says complex. I do believe in a TI you have to find num, and somewhere in there in math, I'd try math or num, it should be in there somewhere. And then you can put an I in. If you can't figure out where it's at, then convert this to the trig form of it, which would be cosine of 45 plus I sine 45. And then to do z squared, you would take this thing and to square it, you have 1 squared times cosine of 2 times 45 plus I sine 2 times 45. And what you're going to get there is cosine 90 plus I sine 90. And cosine of 90 is 0, and I sine of 90 is I. So 0 plus I, and so that coordinate is right up here. Then if we move on to z to the third, you will get a negative square root of 2 over 2 plus the square root of 2 over 2i. Doing the same thing, you would have 1 squared cosine of 3 times 45 degrees plus I sine 3 times 45 degrees. And so that's still 1 cosine of 135 plus I sine 135. And that would put you right here. And then finally, z to the fourth. That is going to be a negative 1. It's 1 squared cosine of 4 times 45 degrees plus I sine of the same thing. And 4 times 45 is 180. Plus I sine of 180. And 180 degrees is a negative 1 for cosine and 0 for sine. So a negative 1 plus 0i is just a negative 1, and that would put you right here. And that still is 1. And if you kept doing this, it's putting these points with the circle radius of 1. Alright, so now moving on to the next question where you're supposed to multiply these two complex numbers together. In order to multiply complex numbers in trig form, you multiply the absolute value or the radius or the magnitude. You can take 11 over 20 times 2 over 5, and then what you have to do is add the angles together. And so simplifying this down, 20 and 2 can be 1 and 10, so you would get 11 over 50. Cosine of 490 degrees plus I sine 490 degrees. Now, 490 degrees would be this angle from here. That's 360, and that would be all the way over to there. And so if you take 360 away, the back of the book is going to give you this answer. Same thing, but you should write an angle between 0 and 360 there. Then if you wanted to figure this out any even more, you would actually put in your calculator cosine of 130 degrees and sine of 130 degrees, and then multiply 11/50ths times those two things to get the complex number that you're dealing with. If it only says multiply and leave in trig form, then you can leave it just like that. And that's probably how it will be on your test. Moving on to the next one, here we are to divide. And just like with multiplying, it's basically the same thing. You're going to divide the two magnitudes, absolute values, and then what you do with the angles is you subtract them. Now these, because there's no degree symbol, are radian measures of angles. And 4.3 minus 2.1 is 2.2. And 2.2 is between 0 and 2 pi, so we don't have to worry about doing anything with that. And like I said with the last problem, if you wanted to get it in complex number form, if it asked you to do that, you would just have to take 5/4 times cosine of 2.2, and then multiply it by sine of 2.2. And then make sure that you're in radian mode so that you get the correct answer. If it doesn't say that, then you can leave it as is. Next question is very similar to the previous one, except first it asks you to write in trig form. So the trig form of 2 plus 2i. You're looking at this on your graph, 1, 2, 1, 2, that's that angle. And so first off, in order to figure out the r, you would take 2 squared plus 2 squared, which is 8, so the square root of 8, and that becomes 2 square root of 2. And then this angle, because it's over 2 and up 2, that's the same amount, so it's got to be a 45-degree angle, so cosine of 45 degrees plus I sine 45 degrees. Then we are dividing by 1 plus the square root of 3i, so that's over 1 and up the square root of 3, and so then that distance right there would be 1 squared plus the square root of 3 squared, so we have 1 plus 3, which is 4, and the square root of 4 is 2. So then we're going to divide by 2, and then this angle, since this is over 1 and up the square root of 3, and b theta equals inverse tangent of the square root of 3, and that's a 60-degree angle. Now then, because we are dividing, then you would take 2 over the square root of 2, and we would subtract cosine 45 minus 60 plus I sine 45 minus 60. And then simplifying this down, the 2's go away, so you would have the square root of 2 cosine negative 15 plus I sine negative 15. And then cosine of a negative is the same as just cosine of 15. And cosine of a negative, sine of a negative is going to be a negative, so minus I sine 15 times the square root of 2. And if you multiply that out, you would get, in this case, 1.366 minus 0.366i. Now in the back of the book for this particular problem, it gives you some answer. I think it's 1 plus the square root of 3 over 2 plus 1 minus the square root of 3 over 2i. And to get to this answer, what they did is at this point right here, they used their difference identities where a cosine of two angles subtracted would be cosine 45 cosine 60 minus sine 45 sine 60. And then for that one did the same thing except used the sine one where it's sine 45 cosine 60 minus cosine 45 sine 60. And figuring out the exact value, which you come up with this here. I will not ask you to do that. So you could leave it just like this. Or if I said write it as a complex number, you would just multiply it out and get that. Moving on to the next one here, using Domoi's theorem to simplify this and expand it into another number. So first thing in the theorem is you have to convert this to the trig form. So first off, you'd have 1 squared plus 1 squared, which equals 2. So our value is the square root of 2. Then to figure out the angle, theta will equal inverse tangent of the imaginary part over the real part, which those are the same number. So therefore, theta is 45 degrees. And so then we would have cosine of 45 degrees plus I sine 45 degrees. And we're going to take this whole thing and raise it to the third power. And from the theorem, it says that you take the square root of 2 to the third, and then cosine of 3 times the angle, plus I sine of the same thing. And the square root of 2 cubed is like the square root of 2 times the square root of 2 times the square root of 2. Those two turn into 2 because there's a pair of them. So it's 2 square root of 2. And then you have cosine of, and 3 times 45 is 135 degrees, plus I sine 135. And then you can even do this a little bit more. The cosine of 135 degrees is a negative square root of 2 over 2 plus I square root of 2 over 2 times the square root of 2 square root of 2. And that would get you, distributing this down, this times that. The 2's would go away. Square root of 2 times the square root of 2 is just plain old 2, so it's a negative 2. And then distributing here, the same thing, except now we don't have a negative, so it would be just plus 2i. And there's the complex number. (97) is basically the same problem as the one we just did, which was 91, except here they've already given you the complex number in trig form. So we just have to take 5 to the third, cosine of 3 times 20 plus I sine 3 times 20. And 3 times 20 is 60, so we have cosine of 60 degrees plus I sine 60 degrees. And 5 to the third is 125. Cosine of 60 is 1/2. Sine is the square root of 3 over 2. And if you take 125 times that, you'd have 125 over 2 plus 125 square root of 3 over 2i. And then you're done. Finally, it comes to our last problem that you wanted to look at, which was number 128, finding fifth roots of 32 cosine 5 pi over 6 plus I sine 5 pi over 6. Here it's already in trig form. If you were to get some number like this, you would first have to convert it to trig form, and then that would be 2 squared and 3 squared, which is 13. So square root of 13, and then cosine, and then you'd have to figure out theta being inverse tangent of 3 over 2, and that would be the angle you would put there. And if this is, since this is in the first quadrant, because you're over 2 up 3, then that would be the angle. Remember, if you're in the second quadrant, when you find this angle, then you have to take 180 minus what you found. If you're in the third quadrant, you have to take 180 plus the angle you found. And if you're in quadrant 4, you have to take 360 minus the angle you found. All right, so then back to the problem. We already have it. Now we know that k has to equal 0 to start with. And so the formula says the fifth root of 32, and then cosine of 5 pi over 6 plus 2 pi times 0 over what the 5, because that's the root, and then plus I sine of the same thing. Simplifying this down, the fifth root of 32 is 2. 5 pi over 6 plus 0 is still 5 pi over 6. Divided by 5 is going to get you cosine of pi over 6 plus I sine pi over 6. And if you needed to, then you would distribute the 2 to these two things to come up with a decimal equivalent for that. In this case, you could simplify to square root of 3 plus I, because the cosine of pi over 6 is a square root of 3 over 2, and the sine of pi over 6 is 1/2. So that's the first root of that complex number. Then you have to go to k equals 1. Still the same thing, fifth root of 32, cosine 5 pi over 6 plus 2 pi times 1 over 5, and then I sine of the same thing. And the fifth root of 32 is still 2. Now we have the cosine of 17 pi over 30 plus I sine of the same thing. And again, if you want to figure that out, then you can distribute this 2 to those two things. Then k equals 2, which is the fifth root of 32 cosine of 5 pi over 6 plus 2 pi times 2 over 5, and then I sine of the same thing. And that answer then still 2, and now we have cosine of 29 pi over 30 plus I sine 29 pi over 30. Probably should explain how you get that, because this is 4 pi. And so you have 5 pi over 6 plus 4 pi, which if you put over 6 is going to become 24 pi. And then 24 plus 5 is 29 pi over 6, because the denominator stays the same when you subtract. And then you're dividing by 5 also. And so dividing by 6 and dividing by 5 means you're actually dividing by 30. And that's how you get there. Next, k is going to have to equal 3. And so it's still the fifth root of 32 cosine now of 5 pi over 6 plus 2 pi times 3 over 5. And then I sine of the same thing. And so figuring that out and simplifying it down, you will get 2 again. And now it's cosine of 5 pi over 6 plus 6 pi. And then dividing by 5, which will get you 41 pi over 30. Next we would move on, so then k equals 4. And now we are at our final one because we were doing 5 roots. So it's still the 5th root of 32 cosine of 5 pi over 6 plus 2 pi times 4 over 5. And I of the sine of the same thing. And then simplifying that down, we still get 2 cosine, and here you would get 53 pi over 30 plus I sine 53 pi over 30. And then that would be it. And then you have your 5 roots of that complex number. There's 1, there's 2, there's 3, there's 4, and there is 5. And like I said, if you wanted to figure each one of those 5 out as far as what the number is, you would take your calculator out and put this into it, and then multiply by 2. And then do the same thing for the sine of that and multiply it by 2. And then you would get the complex number. That concludes the work problems from that section 6.5.